All right, we have one more to go. We have the integral from 0 to ln 5 e to the x over 1 plus e to the 2x dx. All right, one quick observation here is that this integral can be rewritten as, for the bottom of the rational function, as the sum of the squares, right? 1 squared plus e to the x squared dx. Okay, this in fact tells us what the u could be because we're going to rely on to u substitution. But before doing that, let's go back to the table and check out which integral is the most appropriate for this case scenario. I have the second integral. See, the bottom is like sum of the squares because the first and the third come with the difference of squares in the bottom. So I'm going to use this integral here. D over a squared plus u squared equals 1 over a arctan u over a plus c. Okay, so but first we have to have a u substitution, and to do that, first I'm going to tackle with the indefinite integral version. Okay, and once I'm done with that, I will go back and use the first fundamental theorem of calculus. Okay. All right, so, well, since this looks like I have 1 squared here, so this is going to be our u, sorry, this is going to be our a, and this is going to be our u. So I'm going to go with the u substitution, u equals e to the x. And this immediately follows that the u equals e to the x dx, right? So now I'm going to rewrite this integral as, well, e to the x dx is already du, so the whole top becomes du, and the bottom becomes a squared plus u squared. We just checked from our table that this is equal to 1 over a arctan u over a plus c. Okay. Let's go back to the original variable. So a was 1, so 1 over 1 is 1. So arctan u equals e to the x. So arctan e to the x over 1, that's e to the x. But let's put it in the parentheses so we will make sure that e to the x is the argument of arctan plus c. Okay, so that takes care of the indefinite integration here. But we do have a definite integral in the question. So we go back here and just got arctan e to the x part, and don't worry about the c part because c does not have any contribution to the evaluation of a definite integral. Okay, so we're going to use the brackets here, lower limit, upper limit. Okay, so let's plug in the upper limit. Arctan e to the ln 5 minus arctan e to the 0. Okay. Well, you can perfectly use your calculator at this moment, but I want you guys to play with a little algebra and properties of exponential function. So this term here is in fact equal to 5. Okay, e to the ln 5 is equal to 5. Please make sure that you remember this property. And this is, again, this is covered in precalculus. And e to the 0 is obviously equal to 1. So this turns out to be arctan 5 minus arctan 0. Okay. 5 is not a known quantity for arctan, but 0 is. So this is arctan. This is arctan 5 minus arctan arctan 1. I'm sorry, this should be 1, right? I'm sorry, because e to the e to the 0 is 1, and this is arctan 1. There we go. 1 is a known number for arctan, and it's in fact arctan 1 is pi over 4. And go ahead and get an approximation here by using your calculator, and you should get something like 0.588, and I kept 3 decimal places here and rounded it off in the last decimal. Okay. All right. This takes care of part C, and we can call it a day because we are just done with 3 parts of this exercise. And thanks for watching. This is the end of the video. I'll see you in another video. Bye.